All right, so my mic is on now. I was talking before I turned on my mic, and I was commenting on Yolanda's mic was on when mine was not. So that was kind of funny. All right, so we got about a minute and a half. So I will give you a quick preview of what we'll be doing today. So the first thing is I will be implementing the program for the assignment that was due today. And I'm going to use my intuitive method first, and then I'll share with you the like unbelievably efficient method. So this would also be a kind of a good example to show you what time complexity is about. So we'll do that, and then we'll segue naturally into the discussion of time complexity. So that's what we'll be doing today. Let's see, we got about 40 seconds to go. All right, so for those of you who are here already, I put into the announcement a link to a Design Hub recruitment document. And it's just a PDF, but it gives you all the links and all the forms that you might need to participate in the Design Hub in the fall 2021. So the Design Hub, for the most part, will be online in fall 2021, which is okay. It doesn't really stop us, this semester either. So we'll be doing a lot of programming stuff, which does not need to be in person. So there's a need for Unity programming. So if you have been wondering about game programming, but you didn't quite have the enough energy to get into it, not enough motivation to get into it, this would be a good way to get into it because we have a resident expert. He's Tristan Byrne, who used to be a student at ARC. He took basically all of the classes that I have ever taught. um, well, just once each for each one, but he took all the classes. Um, and he's now the resident Unity programming expert of the Design Hub. So it would be a great chance to learn about game development. We'll also be doing game development using Google Scripts. Yes, it doesn't sound very likely, but it's gonna happen. So that's one thing that we'll also do. And by the way, the Design Hub just got the approval to purchase two Apple iPhone 12 Pros, the ones with a LiDAR technology. So that's also going to be interesting because we might look into Apple app development, particularly using the LiDAR feature, so that we might be able to do 3D modeling and 3D scanning using just an iPhone. So that's going to be very interesting work. So in terms of recruitment, participation level, there are three. The first one is an intern trainee. Basically they're unpaid, but there's also not a whole lot of requirement. I don't think there's a requirement of how many units you have to be taking in that semester. So the next level up is an intern tech, which typically would be a returning student, so someone who has participated in the Design Hub already. Typically uh, some of those will rejoin the Design Hub as an intern tech. And then we also have project leads, which actually are classified temp workers. So those are also paid positions. But if it's the first time, it's going to be an unpaid internship, just because of COVID-19. Uh, Budget is a little tight, even for the Design Hub, and we cannot afford to pay everybody, who works over there. But you'll still be earning work experience units, which can be useful, when you need to apply for a permanent position. Even though this is a community college level work experience, it can still be useful because we'll be able to you'll be able to outline what you have done, and some of those skills can be useful and important in an actual job interview. All right, so time is 3 minutes past noon, so I'm going to get started. There's no text channel traffic that I can see. although there's one general channel traffic, which is oh, okay, I see. All right. Okay. So there's nothing specific to class content. Um, all right. So let's go ahead and get started with the program. And I am going to use, as you would probably guess, online GDB for this purpose. So onlinegdb.com, and I haven't even signed in yet. I should probably sign in. It's not required, but if I sign in, then there's no chance I would actually lose the content of the program because it's going to be automatically saved. That's the beauty of being web hosted when you're writing programs. All right. So I'm going to do it the first way, which is the intuitive way of doing this, which is kind of what I expect people to do, in this type of program. So the way we do this, or the way I'm going to do it, is to typically I use a void function unless there's a specific thing that I needed to return. I would just use a void function, and in this case I would say permutations. And now we have to think about what it needs, right? So it definitely needs a const char pointer of the string, where each character of the string represents an outcome of the initial trial. Okay, so that's just going to be argv1. We'll just pass it as it is. Okay, over here. The next one is going to be the string that we'll be printing. Okay, and in this approach, I'm using a different string, so I'm not going to be, I won't be doing a in-place permutation, where the second program is going to do. So the second program, that I'll do, illustrates a very cool technique that I would say, hey, if I didn't read about it, I probably would not be, I would not be able to think of it unless somebody is saying, Tech, but this program really needs to be efficient. Then I might be able to come close to it. But it's really smart. All right, so this is my buffer, for printing, and then we have the number of trials that also needs to be passed. So that's going to be an integer. Okay, number of trials. And let's see, what else do I need? Well, the number of trials is an interesting part. So there's one more piece of information that I need to pass to here, but I have two ways to do it. The information that needs to be passed here is so the number of trials is the number of trials left. Okay, but I don't know exactly where I start or how many trials have been performed already. I kind of need that information because the buffer is also just pointing to the location where buffer points to is where this particular invocation of permutations is supposed to put its choice. Okay, but the entire string is not visible, using buffer. So I kind of need another way to pass that, and that's going to be the last parameter here, and that's going to be a const char. Let's see. Yeah, it can be a const char because we are not directly changing it, so it would just be a const char of output string. Okay, so there are several ways to do this. This is one way to do it. There are equivalent ways using the same idea. Alright, so in the code, because we already know this is going to be recursive, and as a result, the first thing that I would do in a recursive type of definition is to think about the base case. When is the recursion going to stop? When can I say, oh, there's no recursion, this is a simple case, this is what we're going to do. Okay, so in this case, it will be when number of trials left or the number of remaining trials is 0. Now there are two ways to specify this. The first way is the obvious way, which is basically saying when it is 0. But the less obvious and also not Java compatible way is to simply say logical not number of trials. Now this won't work in Java because Java is a little bit more strict when it comes to type checking. So you cannot negate an integer type you can only negate a Boolean type. But in C and C++, a non-zero integer or a non-zero scalar of any kind that includes pointers and doubles and floats and stuff like that, they're all considered a false as a Boolean in the context of where a Boolean is expected. So I'm doing this in a way that is not exactly using the strongly typed method. All right, so I usually automatically put in the if else, okay, because hey, in the worst case, I'll just not be using one of the branches and just leave it empty. But I don't have to worry about indentation or forgetting where it is supposed to go because it's already here as a template. So in this case, because num trials is a 0, so I don't really have anything to do because I'm running out of trials. There are no trials left. So the only thing left to do is to output the output string, okay? And by this time, the buffer is probably, I need to put a null terminator to the entire buffer first, and then I would use output string to output the entire thing. So I'm going to say buffer equals to 0 or asterisk buffer equals to 0 so that we are using a null terminator at the end of the output string. And then the next thing we need to do is to print the entire output string. In C and C++, you can use, well, in C specifically, you can use putS, which is a put string, and then we'll say output string, just like that. And of course, if you're using putS, you need to remember which header file you need to pound include. And I believe this one is standard IO, so it's already okay because standard IO.h is already included here. If you are not sure, okay, which I am in most cases, I would just look it up, okay? So I'm just going to look up put as man page, and then we click on it. So right here, it gives us the pound include header file name, as well as the interface of using putS. It does have a return value, okay? So the return value is an int. Let me see, what is it returning? So it returns a non-negative integer on success or EOF on error. So technically speaking, if I am writing production code, I really should be testing whether putS is returning an EOF or not, whether it's returning an error code. But since this is not exactly production code, and we are just we're focusing on the logic of the algorithm, so we're not going to complicate the program by these additional error handling. I mean, besides, what are you going to do if putS fails, right? I mean, your print statement is failing, okay? You cannot print an error message to report that your printing is failing, okay? So there's really not much you can do. I mean, the only thing you can really do is to exit the program with an error code, just to let the invoking command on the command line know that, yep, something bad just happened. Yep, return something that is non-zero. Doesn't have to be 1, just have to be non-zero. That's a standard. Okay. By the way, this is not it's not required. It's just a standard. Okay. So there's nothing much to do when there's no trial left. So that means that all the recursive cases happens when we do have at least one trial left. Then we have to figure out, okay, what am I supposed to do? So I'm gonna do it the tedious way. It's not the smartest, but it's gonna be the most intuitive way to do this, which is what I kind of expected most people in this class to do it in this particular way. So I'll comment on that a little bit later. Okay. It's kind of interesting as an observation. So I'm going to use I as a variable to help me. Well, it doesn't have to be I. I'm going to change this. See, I'm going to use another pointer, a char pointer, and in this case, it's going to be const char pointer, and it's basically pointing to a character that I might be able to use as an alternative for this particular trial. Okay. So we'll say P choice. Okay, yeah, potentially this is a choice. Okay, one of the choices that I can use. So now we can use a for loop. Okay, so we first initialize P choice to be the beginning of PTR, which is the string representing all the options that I have as the initial trial. And I am done in two ways. So I am done if there's no choices left. I look through the entire thing and I cannot use any one of those. The alternative, and then the other way to exit this loop is to say, yep, I just found one. I can use this one. So now I know that I need something like this, something or something. And then to advance to the next location, I just need an increment of p choice so that I point to the next available character. So let's find out what these two, might be. The first one is when I do find out that a character cannot be used at all, then I need to move on to the next one. And then the second one is when I realize that something is not used and I can, let me think about it. Okay, so to stay in the loop, I need to make sure that I have not yet exhausted all the options. Okay, so that means we don't need an or, we just need to make sure that we are not at the end of the entire thing yet. So we have to say p choice is less than okay, because it's going to be a no terminated string. So as long as p choice is pointing to something that is non-null, I should probably consider it. Okay, there we go. Okay, I'm just looking at the text channel. Well, it doesn't have to be. So to answer, okay, I'll just answer these comments one by one. I've never known it. I'm not really sure what it is referring to, so I can't really comment on that one. And then the next one is, oh boy, this isn't close to what I wrote. Well, that's okay too. There are many ways to express this algorithm. In fact, if I see two programs written almost exactly the same way, guess what's going to happen in my mind? Bzz, 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 alarm goes off. It's like, why are these two programs looking so much alike? It is not possible, because there are so many ways of expressing exactly the same logic. Okay, the same inefficient logic in this case. Okay, this is totally inefficient, but I would say in most cases, okay, people will think of this particular way of doing things first. And because this is a homework assignment and you have other classes that you're taking to, so most people would basically go like, okay, this program is working, I'm just going to move on to the next class, okay, with another homework assignment. So anyway, I'll comment on that in just a little bit too. There we go. Yeah, that's perfectly logical. Okay, if you get a program working, I know optimization is fun, but when you have other homework that you need to do and study, and there's no time to do optimization. Okay, so let's see what we're gonna do here. Okay, so we say p choice is pointing to a potential outcome for this trial. But now we have to decide, hey, but can we actually use it? Okay. So to determine whether a choice can be used, we kind of have to see whether it has been used already or not. Okay, that's kind of something that we have to do. So to determine whether something has been used already, we can utilize output string, because everything that is in the current experiment outcome is in output string. Now, output string is not yet null terminated because our termination is over here. So that means a lot of the functions that you can use that you can use on a null terminated string is not going to work. Okay, if you just use output string as is. But there are several ways to fix this. So we'll go ahead and fix it first. So the first thing we'll fix is to say, hey, we can just say buffer is pointing to a null character, and thereby null terminating the output string. Right here, right at this point, where I as in this invocation of permutations is supposed to figure out a potential outcome and put that outcome into the character that is pointed to by buffer. So I'm just null terminating the whole thing so that I can do a string function. Okay, and there's one particular string function that is really useful. It's called strchr. not sure whether there's a R at the end of it. Let's find out. Okay. You can see I have to rely on Google a lot just to find out how to use a particular function, because I can vaguely remember the name of the function, but sometimes I cannot remember the entire thing. So it is indeed string char, and string char does, well, okay, technically speaking, string and char probably is the better way to do it. But string char returns a pointer to the first occurrence of a character C in the string S. That's kind of what I need to do. Alright, so we'll use that. So now we'll say, oh, wait, because we have to look at the return value too, right? Because what if it is not found? So we have to be able to know, okay, what happens when it is found and what happens when it is not found. So when it is found, it returns a pointer, and if it is not found, it returns a null, which is really convenient. Okay, so as we can see here, so now we need some kind of a conditional statement, right? And in this conditional statement, now just so that I'm consistent, I always use if then else. Okay, so in this case, we know that we're gonna use string char in some way. The string that is providing the characters is ptr, and then the character that we're trying to locate is pchoice. Okay, so pchoice has an asterisk in front of it because I'm trying to specify a specific character in the string that ptr is pointing to. Okay, because I'm considering using that for this particular trial as an outcome for the trial that this invocation of permutations is trying to figure out. And then ptr is the beginning of the entire string, so so that should work. And if it is found, then there's nothing to do if it is found. Okay, if star pchoice is found, we cannot use it for this trial because it has been used in the previous trial already. So oh, I just made a mistake here. We should not be using ptr because it's going to be found in ptr, because ptr has all the options, right? So the variable or the parameter that I should be using is output string. Okay, there we go, output string. So we are trying to figure out whether a specific character in ptr, the string pointed to by ptr, is already used by a previous trial, because output string is recording all the previous trial, the outcomes of all the previous trials previous to the one that I'm dealing with right now. Alright, so my mistake here. Well, good thing I was typing the comments, right? Because if I were not typing the comments, I would not have discovered the mistake, because it wouldn't occur to me that I should be searching in the string that represents outcomes of previous trials instead of the string representing all the possible outcomes for the initial trial. So that's another reason why you should be commenting your program, because guess what? It just saved me, and when I'm writing this program on the fly. And this is also why I kind of write these programs on the fly instead of doing this way ahead of class. Some people may say, but Tech, you're just making excuses of winging your classes. No, I'm not. I thought about pre-writing a program prior to the class, but if I did that, I would have found these mistakes offline, and even if I were to discuss it, it wouldn't be the same as making the mistakes as I talk about it. Alright, so the else case is the interesting one, because the else case is saying, nope, this particular outcome has never been used in the trials prior to the one corresponding to the for the current invocation of permutations, the subroutine. So we can use it, right? So that's the whole point, is we can use it. So now we can say we can use star pchoice at the position of star buffer. So now we say star buffer equals to star pchoice. So we're copying a character from the string pointed to by ptr. Well, it's one of the characters in that string. We're going to copy that character to where buffer is pointing to. Now buffer is just a moving pointer for output string. So which previously was null terminated over here, so I can safely use string char. But now that I have figured out what outcome can be used for this particular trial, I just go like, okay, let's use that one. So now I'm basically saying, okay, this trial is figured out. Let's move on to the next trial. Okay. So this is where recursion comes in handy. So we say basically permutations, so that we can recursively call permutations, and then we have to figure out what to do with all the parameters. PTR is going to be PTR because PTR has to be pointing to the beginning of the string representing all the available outcomes, so that cannot change. Buffer, on the other hand, needs to be incremented. We need to add one to buffer before we pass it as buffer, because we need to move on to the next location of output string and say, hey, the next trial is going to use that location, not the one that I just used earlier on line 32. And then the next one is going to be num trials. The number of trials yet to perform is going to be one fewer, so we'll use num trial -1. Note that I am not saying plus buffer or minus num trial. Okay, all I am doing is just to compute the value that I need to pass, but not changing the parameters themselves. There's no need to change the parameters themselves. And then the last one is output string, which also should not be changed. So output string remains exactly the same because it should always be pointing at the beginning of the string that I need to output, because that one, it cannot change, it cannot float. There we go. So now we have permutations calling itself recursively when I do have a choice. That makes sense. And if p choice points to something that have been used already, I just basically do absolutely nothing in the conditional statement, which basically just ends up going back to the beginning of the loop, or it goes to the post condition first, basically incrementing to the next available choice if there's any, and then I check whether I have run out here, then I exit the entire for loop. If not, I just checked it again and basically do the same thing. I'm not going to shoot for a super bulletproof program, and I'll do the bad programming practice of just calling permutations right away with argv1, because that presents the choices. Oh. Okay, so I was just chuckling when I read the text messages. Okay, so argv1 is all the choices, or did I flip the order? Which one is supposed to come first? The number of trials or the available choices? Stream is still offline. My internet is cutting in and out. Alright, so let me check. Oh, okay, I see. Okay, gotcha. Alright, so getting back to OBS. There we go. Can you guys see the live stream and also hear my voice? Okay, cool. So my voice has always been on, it's just the screen has cut out. That is weird. It's not as weird as one time when Discord just completely crashed, and it was also putting a lot of load in the system too, and then it just crashed. Okay, alright, so so getting back to the program, I'm not really sure how much time we lost. Let's see. We lost maybe a minute, so it's not too bad. Okay, so getting back to the main program, I need to find out from the homework assignment what is the order of the parameter that I need to pass. Yes, I made the homework assignment and I forget about which one is which one. Alright, so let's see, go back up. It's the omega generator. That sounds like a character in some kind of anime. All right, so it is the number of trials first, and then a string representing the possible outcomes, the available outcomes. All right, so let's go back to online GDB. And obviously, it's hard to find online GDB now, and this is why I have tab search. So now I can just type online GDB, and apparently I have two of them. Okay, this is not the one that I want. Alright, so let's find the other one. Actually, I might as well close this one first so that it doesn't find this one again. Alright, there we go. Oh, okay, there we go. So this is the correct one. Okay. How many tabs do I have open? That is a very good question. I would say a lot. These are the tabs that I have opened up to now, and this is only for one profile that I have used in Firefox. Sometimes I have 4 profiles, all open, in separate they call it separate workspaces, in Linux. So yes, a lot. And this is why I need to be able to search through the tabs, because I can't, even with a vertical tab thing, even with this, okay, I can show you that too. So even with a vertical tab tree, vertical tree tabs, sometimes it's hard for me to find the tab that I need, because I'm doing a lot of research too. That's basically what in the text channel. Remember I said, I have to do my own assignment, and that's because I'm teaching CISC440, which is a mainframe, IBM mainframe class. So I've been doing a lot of tabs to research, what terms means what in the world of IBM. So so that's partially why this happens. Okay, so we have to so this is not ARGV1, it is actually ARGV2, which is the third argument, which is the string representing all the available options. And then we need to specify the second argument, which is buffer. Oh, this one is going to be fun. All right, so how do we allocate for buffer? Okay, so in other words, we need to do something like this for buffer, because buffer is, supposed to be a local variable. Yes, I know some of you are thinking, but we can use, a global variable for buffer because it doesn't really change. It just keeps going, right? And same thing for output string. Actually, this should be output string. All right. So now the question is, okay, first of all, I do not like the use of global variables, because I have worked in industry before, and programs written with a lot of global variables are very brittle. Okay, so just trust me. Okay, generally speaking, they should not be used unless they're const. Okay, so if you want to define some global constants, so that every single thing within the program can refer to the same constant, that is okay. But if you want to define anything that will change, it's not a good idea to use global variables. All right, so now let's go back to try to answer this question. Okay, how do we specify the size of output string? Well, as it turns out, this is actually okay in C and C++. So you can actually say string length of argv2, and obviously argv needs to be a parameter of main. So we now have to say the first one is always argc, the number of arguments, and then the second one is a const char pointer of argv, because technically speaking it is an array of strings, and an array in C or C++ is also known as a pointer. So that's why it is a pointer to a pointer, because it is an array of pointers. So that's the fun part of using C and C++, because the concept of a pointer and the concept of an array, they overlap a lot, and in some cases very confusingly too. Alright, so this construct here, should be specifying, however long, argv2 is, allocate a buffer that is the same string length plus 1. The +1 is because the null character is not counted as part of the length of argv2, the available options or the available outcomes for the initial trial. So the +1 is needed because we need that one extra byte for the null terminator in case the number of trials matches exactly the same as the length of the string that we're passing to main. Alright, so that's that, and now we need to specify what? The second thing is buffer. So buffer is initially it starts at the same place as output string, so we'll just use output string in this case. And then the number of trials is argv1, except we have to use ATOI, ASCII to integer, to convert the string into the actual integer value. So I'm not doing any type of error checking here because I mentioned in the previous class that you can assume that I won't trick you and try to pass something that is not legitimate. So we can assume the arguments presented to main, they're all reasonable, and also correct. So that's why we can just go ahead and say, okay, we know this is going to be a base 10 string, base 10 integer string, and just convert it. So that accounts for num trials, and then the last one is output string, which in this case is just output string itself. So there are two output strings because this one needs to always point to the beginning of the entire output string. This is the one that needs to move along as we perform nested recursion, but they both, the one that floats has to start at exactly the same place, and that's why we see two instances of output string in this case. Alright, I'm just double checking, making sure I'm still streaming. So it is still streaming. Very good. Alright, so I think this may be it. Okay, so we'll go ahead and try out. Before we do that, I'm just going to do Control A and then a Control C just in case, right? And I'm going to put it into my own mouse pad just in case something happens. And oh, there we go. So I've just pasted the program here. So this way, in case something happens, I have a backup. There we go. Alright, so now we are ready to run the program. So we get to debug. And it complains about some warnings. Okay. Alright, so it complained about some warnings. Most people look at this and go like, well, if it's not red and it's not an error, I'm going to ignore that. Well, let's not do that. Okay, because it's usually if you have a warning, typically it is telling you something may be wrong. Alright, so it's complaining about string char as it's not declared anywhere. And I do have standard IO defined here. Alright. So that means string char may be defined somewhere else. Oh, right. Never mind. String char is defined in strings.h, so it's a different place. I was thinking about put s, which is already defined in standard IO, but string char is not. Okay, that's my mistake. Alright, so pound include, I think it's strings.h. Might as well look it up. String char and page. String.h. Okay, there we go. Thank you, Anita. There we go. Alright, so get back here and try again. Debug. Okay, so this time it tells me ATOI is not defined. Let's find that one too. And this one is in standard library. Okay, so we'll pound include that too. Oh, keep forgetting that I have to stop the debugger before I can edit the source code. There we go. Standard library. All right, try it one more time. All right, so now when we run the program, we're going to have to follow that order where the first character represents the number of trials, and then the second part is the string, each character of the string representing a potential outcome of the initial trial. So we'll try the ABC first, okay, which is what we have been using, for illustrating the possible output. Okay, so that seems to work, right? I mean, AB, AC, BA, BC, CA, CB. Okay, that seems to good. That seems good. So we'll try something else. So we'll try to A, B, C, D. So this will give us all the permutations with only 2 characters. And Ivan says it would be a good idea to save the code you got to a notepad and avoid the loss of code if you accidentally reload the page. Yep. Or either that, or you can actually sign in, because if you sign in, then the file is actually saved, on their side, which is great because you don't have to save it locally either. Okay, so getting back to the program. Okay, so when I try ABCD, the program ran, and so in this case, I'm looking and I have to make sure that I don't have any repetitions. So, the same permutation should not appear more than once in the output. And in this case, I do not see any repetition. I mean, just quick scanning by using my eyes. I don't see any duplicate output. So that's good too. Oh, this is not efficient. Trust me. The next algorithm that I'm gonna show you guys is far more efficient than this one. Okay, so before we go there, okay, before I present the next one, we'll take a look at this one and try to come up with a time complexity, just roughly. Okay, we don't need the exact, just a rough time complexity. All right, so we can see that each invocation of permutation involves a loop, and the loop goes from the beginning of all the possible choices, and it goes all the way to the end to figure out which one can and which one cannot be used. So it may seem like that for each invocation, it is already proportional to the number of possible outcomes. But that actually is not the case, because we also have a string char here. So string char has its own internal loop, okay, so that makes this algorithm makes one single invocation of permutations is already n squared, and n in this case would be the length of the string that I pass to be all the available options. So each invocation is n squared already. So we have to multiply that by the number of trials, which is independent to the length of the string. So the product of these two, basically it is the number of possible outcomes for the initial trial squared times the number of trials is going to be the time complexity of this algorithm. That makes it not very efficient. Okay, but it is still it works. Okay, it is correct in the sense that it works. And time complexity was never a consideration in the homework assignment. I did not ask for the most efficient way of doing this, so it's perfectly okay. This solution is fine. Okay, that's not a problem. Okay, so in the text channel we got some comments for the if statement inside of the for loop. We don't have anything. Yes, that is correct. This is how I code things. Sometimes is I figure out, hey, when p choice points to a character that has been used already in prior trials of this experiment, I cannot use it. If I cannot use it, there's nothing to do here. So I could have, okay, to answer Anita's question, I could have negated the condition and then move the else case up here and then not to have an else case anymore. In other words, I can flip the polarity of the condition so we can get rid of the else case by putting what is currently in the else case into the then case, which is what most people do. I just a lot of times I leave my programs exactly like this, just in case, right? I mean, just in case there is something to do over here later on, because I want to do something here when a choice has been used already. I have a place to put that code when there is such a need. But if I remove the condition, if I remove the branch and then invert the condition, then it gets a little bit harder to find a place to put that else later on. So, but that's just me, okay? That's just me coding in my particular way. Space complexity is just proportional to the number of outcomes for the initial trial, because the second string is exactly the same length as the first one. So it is still proportional, to that, even though, it uses like 2 copies now, right? Because you need the space for argv2, and then you also need the space for the output string, and they need to be the same length. But in terms of, how it scales, it's still going to be just proportional. So it's not too bad. Plus, we also have it's also recursive, so there's another portion of the space that is going to be consumed on the stack, because each level of recursion consumes some stack space. So that part is completely independent to the string that's being used, but it cannot be the depth of recursion cannot be deeper than there are elements in the string. There are characters in the string, so that means everything is still proportional to the length of the string itself, even if you take into consideration of the space used on the stack because of recursion. So that's a good question. That is a good question. It doesn't really change what it is proportional to. It just changes the scaling factor, or the coefficient for that. All right, very good. So now we're gonna copy paste this, and I can put it into the text channel. All right, where's my mouse pointer? Oh, there we go. Sometimes I lose track of the mouse pointer. All right, so I'm gonna put it in the channel here, and that. This is why I like Discord, because I can do something like that. I can copy and paste code, and if I use the backtick, or backquote C, then it understands this is in C syntax, and it automatically puts in syntax highlighting. You cannot do this in Zoom. You cannot do this in most of the other communication platforms. But Discord, hey, it's built for this sort of stuff. Cool. Okay. So now we look at this and go like, how can we make this more efficient? So the way we make this more efficient is to do a in-place permutation, where buffer is the boundary between what is used and what is available. So that is a very it's a very smart algorithm. It's a very smart way of doing things. Oh, okay. Well, thank you, Aiden. You can upload the file too. Okay. Well, since I never really saved this program as a file, that was not an option, but it's good to know. It is good to know. All right. Right. Getting back to how to make this more efficient. All right, so to make this more efficient, there are several things I need to change. Okay, so the first thing is, because it's going to be in-place permutation, so technically speaking, if we're doing an in-place permutation, I cannot pass argv2 the way I'm doing right now, because argv2 is a pointer to a char string, which is not supposed to be changed. So that means I still need output string declared exactly like this, but I also need a string copy to copy whatever argv2 has to output string first. Then I can just use output string without referring to argv2. So the first thing we need to do, so I'm modifying the program now. So the first thing we need to do is a string and copy, and the string and copy actually. Yeah, this is going to be circular. There's no need to use string and copy because if it's unsafe to begin with, it's going to be unsafe anyway. So there's no way to save ourselves from this one. So we're going to string copy to output string from argv2. Okay. So after that, we don't need argv2 anymore because output string is a copy of that already. So from here on, we just use output string, and the number of arguments is going to change too because there's no need to pass one of them anymore. All right, so we go back to here, and the way we change the algorithm is we're using buffer still as a bookmark to separate the two parts of the output string. The first part is already those are already chosen. In other words, they represent outcomes that we have chosen for trials that are previous to the one that I'm dealing with in a particular invocation. But between these two, between PTR and output string, they're going to be the same, so we can get rid of one of them. So we'll get rid of the last one. So output string is no longer going to be one of those. And we can also, because there's no output string anymore, we'll just use PTR in the put as statement. Putting a null terminator before we use put as is still probably a good idea. Okay, so we'll keep that. So the recursive call is now a little bit different because we're going to use a swap, okay, to do some of the interesting work. Someone asked me about, can we use the standard template library swap, and the answer was no, because swap is really easy to do. You can just define swap pretty easily. Not as a template function, there's no need to do it in this context. So it's just going to be PTR1. I mean, this is actually what my assembly programming class is doing. That's their previous lab, is to implement this in assembly code. So, for people who are taking both classes, this really should be an easy one if they choose to use the swap subroutine and use this particular method. And then we have PTR1 equals to PTR2, and then PTR2 gets T. All right, so this is just for switching the content of the two characters, one pointed to by PTR1 and the other one pointed to by PTR2. So that's a fairly standardized swap kind of logic. So some people may ask, but why do you need swap in this case? So the way this works, okay, is because buffer is basically a bookmark. Okay, it's a bookmark separating the portion that is already determined, the outcomes of the previous trials, versus the portion that is still available. So basically, I don't have to compare anymore because everything up to but excluding what buffer is pointing to cannot be used again. But everything from where buffer points to all the way to the end of the string pointed to by PTR, all of those can be used. So the for loop is a little bit different now because p choice is still needed, but it doesn't need to start from PTR anymore. It doesn't have to go from the beginning. Instead, it can now go from where buffer is pointing to right now, and as long as p choice is not a null terminator, which is put in by the string copy to begin with, then I can continue. And so the overall logic is not changed here. Okay, so I'm scanning from where buffer points to, and not all the way from the beginning of where PTR is pointing to. So what makes it kind of interesting is there's no need to null terminate the output string because we no longer need to use string char. Okay, we don't need to compare anymore. So I'm deleting a whole big chunk of logic because I don't need to compare anymore. Everything from where buffer points to all the way to the end of the string, all of those are available. Okay. So the trick now is to say, if I use a particular choice, I am going to swap it with something. So I'm going to swap a character after where buffer points to with where buffer is pointing to. So this way I'm exchanging the location of a choice that I can use as the outcome of the current trial, so that it is at the right place. But I'm also making whatever buffer is pointing to now become available to a later trial, as I do the recursive call. So the swap is really cool because it's a very inexpensive operation. It's a constant time operation by itself. So we are going to swap whatever buffer points to whatever p choice is pointing to. And of course, I was just being stupid here because I need to pass the pointers, not what the pointers are pointing to, because this is the only way regular C can change. Can have the same effect as a pass by reference parameter, because in plain C there's no such thing as passing by reference. So you have to pass by pointer, and then you change whatever the pointer is pointing to. Alright, so the rest of this is about the same, except we don't have output string as a argument anymore. And incrementing buffer is proper. Okay, that's exactly what we need to do. But when we come back, we have to swap again. So because we have to swap back before the next iteration, so that we are not permanently changing the rest of the array. So this is actually needed. Let me think about whether it's fully needed or not. Yeah, I think it is needed. There might be a way to get rid of one of the swaps, but I think it is needed. All right. So I think that's it. Okay, so you can see the code is getting simpler. I got rid of a conditional statement, and you can see how this pair of braces from line 33 to line 38, there's nothing corresponding to these braces. There's no conditional statement, no loop corresponding to these braces, which means they are not needed. That is really cool, because we just made the program simpler in terms of conditional statements, logic, and stuff like that. And we are introducing a swap operation. But a swap operation, as I said, is a constant time operation by itself, instead of something like string char, which depends on the length of the string, right? So this is actually more efficient. We are reducing the time complexity of the n squared down to just n, okay, which is proportional to just the length of the string itself. Yeah, I'll upload it too. Okay, but I'm not going to upload it until I know this works, right? Because I'm actually making this up as I go. I learned the general idea, but I didn't test it. So this is completely untested. Okay, we're going to test it now. And once again, I'm not winging it. I want to do this in real time, so that if I do make a mistake in real time, I can also show you guys how to debug a program, which most people cringes on. Most people would cringe when they say, oh, okay, now you need to debug the program. To me, that is actually the fun part of programming. But before we get to debugging, we have to fix the program. Okay, so swap doesn't like it because we are passing a const qualifier of p choice. Oh, okay, right. Okay, we can't do that. So p choice cannot be pointing to a const char, because if you say p choice points to const char, then whatever p choice is pointing to cannot be changed. Okay, then that kind of defeats the whole purpose. We cannot. That's not what we want to do. All right. So if I fix one mistake, I'm gonna try again, compile again. And now we have too many arguments to function permutations. We kind of know that, but we want to know where the recursion is coming from. There we go. Yep, output string is the same as output string at the beginning, so that's why we removed one of the parameters. And okay, so I think that's it. Let's try again. Cool. Alright, so we'll try again with 2 and then ABC. Now it's not working. It only gives us A, B, and BA, so C is completely, it's not getting to C at all, which tells me this loop is exiting too early because it's not considering using C to start. So this is the debugging part. Okay, this is where what I just told you a little bit earlier. If I did this early, and I just debug the whole program and then I present a perfectly done program, then I wouldn't be able to tell you how to debug a program. Now that the program doesn't work, I can show you how to debug a program. Alright, so the first thing is to look at the symptom. Okay, the symptom, it is almost as if we only have a string of AB instead of ABC. So you can test by saying, okay, what if I give you the string of ABCD? Because if the output of ABCD is different, then we know we are not, it will help you differentiate, which way it is. Okay, so right now it would seem very definitely that we only go, this loop here is not looping through the whole thing. Okay, we are terminating the loop too early, and we only consider A and B. So what we do is we can statically look at the code and analyze the code and look at the symptom and figure it out. Most people would just kind of put a breakpoint and just go into the debugger and figure out, okay, what am I missing? I personally prefer to analyze the program and go like, okay, why is the program terminating the loop too early, just by looking at the code. But this one is kind of personal. Different people have different preferences of how to debug a program. But since this is CISP440, I'm going to teach you guys, well, not teach you guys, but I will show you guys how to use the more analytical way. And if that doesn't work, I can always fall back to the more empirical way. Alright, so the loop is, we know the recursion is ending correctly. In other words, when we count the number of trials left, it does terminate correctly, because we can see the output string, they both only have 2 characters, so that is not a problem. It is how the choices that we make available to us for each trial. Okay, that is the problem, and that is controlled by this loop here. So we're going to take a look at this loop and basically run the code in our own head, to figure out, why is it potentially not working. Alright, so pChoice is initialized to buffer, and buffer does not change, but pChoice does increment for each iteration, and we get out of the loop when pChoice is no longer when pChoice points to a null terminator, we get out. So, oh, okay, I see exactly what the problem is now. Okay, because the string is null terminated because when we print it out the first time, when we printed out AB, it put a null character to overwrite the character C. So from that point on, the string only has 2 characters because the rest of the string is done, is gone. Okay, so that means we only want to do this when we are printing. There are several ways to fix this problem. No, we don't really have a whole lot of ways to fix this problem because we lack the information of how many characters it's supposed to print. Well, we can compute that. Okay, I'm sorry, I was just thinking out loud. I was talking to myself. I'm just thinking about what is the best way to do this. Okay, let's go ahead and take a look at all the alternatives of putS. Okay, so we're going to use putS man, and we'll take a look at the alternatives, because what I'm looking for is a way to specify where to start and where to end, and unfortunately there's no easy way to do that. But we do have putchar, which only prints 1 character at a time. I think we can do that. Okay, we can make our own loop to print one character at a time so that we don't have to null terminate anything. Alright, so let's go back to the program, and instead of using putS, which is nice to have, but since I can't really disrupt the string because I'm doing in-place permutation, I can't do something like this. So, we can just go ahead and do it this way. Yes, but then you still have to. Okay, so Damon, not Damon. Dang it, Aiden. Aiden just put out some a code here to use printf so that we can specify the length of the string that we want to print, and this is a very cool way to do it, by the way. Okay, so Aiden, good job finding out how to do this. But you still have to figure out the number. In other words, you still have to use pointer arithmetic because you have to subtract PTR from buffer to find out the number of characters to print. So I'm just gonna make a loop here, and do it the what we call the old-fashioned way, right? So we'll say while PTR is less than buffer, and we'll use putchar this time. Whatever PTR is pointing to. There we go. Because PTR is always at the beginning of the entire output string, so I start with that. And of course, I forgot the increment. There we go, post increment. And so as I increment, your PTR will point to the next character, and then the next character, and then the next character. So by the time it equals buffer, I should stop. Because buffer is pointing to the location where I should be printing, that I should put the outcome of the quote-unquote current trial, but I have no trial to perform now because num trials is 0 at this point. So that is, and then I need one more putchar, and you guys will go like, why do you need one more? Because I need the end of line, because putS automatically put in the end of line character, and that's why you don't see all of the outcomes on one single line, which is going to be very difficult to read. So I need to put out the node. This is the new line character. Okay, ASCII of 10 is the new line character. Yes, I'm hard coding this, and which is not a very good programming practice, but I just want this to run in this context. So we'll go ahead and give it a try. So let's debug again. And it complains about some stupid syntax error that I'm usually making. Line 27. Yes, I forgot about the semicolon. There we go. Alright, so let's try again. 2 ABC. It should print out 6 lines with no duplicates. There we go. It seems to be correct. And we'll try ABCD. And it prints out the correct number of lines without duplicates. Okay, so the key is without duplicates. Because if a program outputs something that has duplicates, well, that's going to be a problem, right? Because a set is not supposed to have duplicate elements. All right, so this is the alternative, okay? And I'm going to copy and paste it into the text channel too. So copy and paste. There we go. All right. So what I do have to say about the alternative, this kind of really super duper efficient way of doing this is, this is something that I would not think of, if I were to do this homework assignment and the only thing that counts is whether it is correct or not. Okay. When I made this homework assignment, I'll put it this way. When I made this homework assignment, I was hoping that people would write their code independently and just basically just trying your best to implement the program. enhance what some some of the text messages in the general channel said, okay, I hope everybody's suffering. So it's not really I think that was a comment basically saying this is a difficult program to write, because if you need to write this program from the ground up, from scratch, without referring to existing known algorithms, and there are tons of permutations algorithms already if you just Google. Okay, but that was not the whole point. The whole point was not I don't want you to show to me that you know how to Google. I want you to show me that you know how to convert the logic that we talked about in class into actual program code. Okay, so those are two different skill sets. I'm not saying one is more important than the other one. What I am saying is, in a class like this, when I give you a programming assignment, I was expecting people to come up with their original way of doing things and not to look up the internet and find out how to do something from the internet. Okay, so I think that is really kind of important, is to differentiate between the skill of Googling and the skill of actually writing the code from the ground up. So I'm not going to fault anyone. Okay, if I see a solution that seems like copy from the internet, or seems to be heavily inspired by something from the internet, I'm not going to fuss about it too much, okay? Because all the homework assignments add up only to 20% of the grade. But I think those people just denied themselves an opportunity to really exercise their own mind, their own logical thinking, to figure out a solution. That is genuinely what I think of. Okay, so no right nor wrong. Okay, but I think people who looked up, use Google, find references and find out how other people did the same thing, they denied themselves a chance to exercise their mind to solve problems. I'm not going to say whether it's right or wrong, good or bad. It is what it is. All right. So we spent a lot of time, unfortunately, on this, and so I don't have a whole lot of time left for the time complexity stuff, but I will still continue with that because otherwise we definitely won't have enough time to finish all the topics. I mean, this class is when I'm teaching this class, it's not unusual that we don't have enough time to cover everything. So I do have to kind of hurry up a little bit. Alright, so getting back to big O, little o, omega, and theta. Alright, so quick reminder is these really kind of archaic terms. You can kind of see these things using more common terms. Like when I refer to the term supremum, you can kind of think of it as maximum, and then infimum is kind of the same as minimum. And we talked about the concept of a limit of a sequence, where each element or each item in the sequence is computed in a very specific way. And the sequence that we left off, okay, that we talked about last time, was x of I is -1 to the power of I. So it's -1, the whole thing, to the power of I. I should probably make a clarification of that in my notes. So give me a second so I can fix that. And then there's some, oh, okay, I thought that was some text channel traffic. Right. Okay, so I just located where I need to put in an extra pair of parentheses so it is clear what I mean by that. There we go. So I'm republishing the document with the extra pair of parentheses. All right, so we'll update here. All right, so in the text channel of today, there's a message that says, "Isn't it true that writing something from the ground up requires some sort of base knowledge that not everybody possesses?" The omega function that I talked about in the context of counting, that is a basis. Okay, if you've implement the omega function, as it is specified, it will get the job done. Okay, that will get the job done, but it's going to be supremely inefficient because it relies on set operations, and generalized set operations are never efficient. Okay, you can use the bitmap approach, and I cannot remember whom, but somebody asked me, so what is the largest case, that I might throw, to this program? And I said, well, since we are talking about one character representing an element, and each character is only 8-bit wide, so you can only have really up to 255 possible outcomes for a trial. And as a result, you can only have up to 255 trials. So that would be the worst case. Okay, and if you think about all the printable characters, okay, so I know a lot of characters are non-null because out of the 256 bit patterns of 8 bits, only one is a null character. So that means the other 255 are non-null characters and technically can be used as an outcome of a trial. But if you think about all the printable ones and all the ones that are printable in a way that they don't give you a line feed or they don't give you a carriage return and special, they don't ring the bell, okay? If you think about all of those, we don't really have a whole lot, right? We have 26 lowercase, 26 uppercase, the digits and then the punctuations and stuff like that. I'm going to guesstimate around maybe 100. Okay, so realistically, I can only give you, a the number of trials being 100, and the string having about 100 characters in it. That would be kind of the worst case. Yep. So Aiden figure out the exact number, and that would be what, 96? No, I cannot do my math. Okay. So we are looking at 126.97. Thank you, Aiden. So we're looking at 97, and I mean that's kind of it. That gives you a lot of permutations already. If I really make that happen, we are looking at a huge number of number of permutations already. But the program should be able to handle any case that I throw at it. Okay, given those limitations. So I don't want people to write programs that are statically designed to say, okay, we can handle up to 5 possible outcomes, or we can handle up to 6 possible outcomes. No, I want a general approach that resembles the logic of the omega definition, the omega function definition. So that's kind of so I that kind of answers the question, or this is what I think of the question or the comment of writing something from the ground up requires knowledge or some kind of base knowledge. But given that the omega function or the definition of the omega function is given, and what the algorithm is supposed to do, I was kind of expecting people to be able to do that. It might not be reasonable expectation to some people, but at least in my mind it was reasonable. Okay. So now we move forward with this stuff here. Okay, so we only got like 2 minutes and a half left. So I just want to re-establish the context from last time. And now this document is updated. So the change is right here. There was not a pair of parentheses. There were not a pair of parentheses before, and now there is. Because I want to emphasize that x of I is just defined to be -1, the whole thing to the power of I. So in this case, there's no limit. Okay. The reason why there's no limit is if I define, if I say, okay, let's go back to the definition of limit here. Okay, so the definition of limit is over here. So if I choose epsilon to be 0.2, okay, that's just a number that I picked out of thin air. If I make omega epsilon to be 0.2, then I can no longer satisfy this requirement. I can no longer find an m, which is a natural number, so that I can find another number called k, which is the limit, so that k, if I take the absolute value of k, whatever the limit is, minus x of j, that absolute value has to be less than epsilon. That cannot happen anymore, because if the sequence is alternating between 1 and -1, there's no way that you can find a value that is less than, let's see, 1. Okay, if epsilon is less than 1 and greater than 0, this requirement cannot be met, and as a result, it does not have a limit. Okay, so there might be sequences like that when we are trying to analyze the time complexity of an algorithm. So now the question is, what do we do with those time complexities? The answer to that question, I will only give you the context, but you guys will have to kind of read through the rest, like 3.4 and 3.5, to understand what we are talking about here. So the solution to the problem that we have, okay, which is an oscillating function that does not decrease in terms of the amplitude of the oscillation. So the answer to the question is we have a limit superior, and we also have a limit inferior. They loosely translate to the minimum of the maximums and then the maximums of the minimums. Okay, so instead of talking about everything approaching to a single point, we can now say if you take all the maximums, okay, and take the minimum of all the maximums, there is a minimum of the maximums. Okay, so the upper part of the curve, okay, the envelope, okay, does converge to a particular value, and then you can do the same thing with the minimum. So if you take the maximum of the minimums, that also converge to a particular value. So even though the maximum of the minimums and the minimum of the maximums do not equal, because it keeps oscillating between those two, they do converge. Each one converges to a particular value, and then at that point, things are just oscillating within the envelope. Okay, so you can still define an envelope as I approaches infinity, the oscillation will be contained within a certain envelope. That's basically what limit superior and limit inferior are trying to do. We are running out of time today, and I will continue this discussion on Wednesday. So I would strongly suggest everybody to read this, because it does get a little bit difficult to understand, because we are applying infimum, which is sort of minimum, and we have a nested supremum, which is sort of maximum. So even if you were to replace infimum with minimum and then maximum supremum with maximum, it is still a little bit archaic. It's still a little bit not archaic. It's still a little bit convoluted, okay, to read through and understand this stuff here. So I would really kind of suggest you guys, spend some time to read these sections before we meet again on Wednesday. Alright, so I think that's all I'm going to talk about today. I might stay online for another few minutes or so, just in case people have questions. But I can stop the live stream now. Alright, you guys have a nice day, and I will